Alright, so again, part 2, last problem. If you haven't done it already, pause the video and minimize the cost. Unpause me, ready to check your work. Alright, so we should end up with the dimensions that will minimize the cost are the width is the cube root of 20 over 3 feet, the length is 3 times the cube root of 20 over 3 feet, and the height is 50 over 3 times the quantity, the cube root of 20 over 3 feet squared. Again, you can leave the numbers like this, round to 3 decimal places, pay attention to what the directions ask you for. You do not need to rationalize these numbers. That is not what I'm trying to test you on here. Alright, so now let's look at how we come up with that. So first, again, I want to recognize there are no endpoints because these will be open intervals. And how do I know that without doing much work or without actually finding the restrictions on the length, the width, and the height? Is by recognizing that all of them can be infinitely close to 0 but can't actually be 0. So I know that that's going to be an open interval there. And I know the other end of the spectrum will also be an open interval for all of those. I don't need to actually find that value in this case because I don't have to test it. Okay, so what relationships do I know? Well, I know the volume is length times width times height. I know the length is 3 times the width. I know the volume is 50 feet cubed, so if I substitute in 3w for L here, I end up with 50 equals 3w squared times h, and so I know h is 50 over 3w squared. Now I come up with a cost equation. Well, the cost is $10 times the area of the bottom and the top, which is the length times the width, and there's a bottom and a top, so I multiply that by 2. There are 2 sides that the area is length times height, and that's $6 each, and then there are 2 sides that the area is width times height. Those are also $6. So now I want to substitute in everything to get it all in terms of w. So L is 3w, L is 3w, h is 50 over 3w squared, w is w, and h is 50 over 3w squared. Simplify and combine like terms. And I get a cost equation that is 60w squared plus 800 over w. Take the derivative. C prime is 120w minus 800 over w squared. Rewrite this as a rational equation. So I get 120w cubed minus 800 over w squared. Find the critical values, so set the numerator and denominator equal to 0. So I get w equals the cube root of 20 over 3, and w equals 0 are my critical values. Again, I know that w can't actually equal 0, but it's important to put that on my increasing and decreasing chart. If nothing else, it shows me that I have to restrict this interval. Now, granted, I would know I'd have to restrict that interval anyway because w can't be 0, but it's nice to show it here. So, since c prime of w is less than 0 on the interval 0 to the cube root of 20 over 3, and c prime of w is greater than 0 on the interval cube root of 20 over 3 to infinity, I know at w equals the cube root of 20 over 3 is a relative minimum. So now, again, pay attention to what did the question ask me for. It asked me for the dimensions. Again, this question could have asked me for what is the minimum cost. It didn't ask me for that. It wanted the dimensions, though. So the dimensions are w equals the cube root of 20 over 3 feet, L is 3 times the cube root of 20 over 3 feet, and h is 50 over 3 times the cube root of 20 over 3 feet squared. Alright, so when optimizing, identify what you're trying to optimize. Write that equation, try to write it in terms of one variable. Take the derivative, find your critical values, identify the domain, and determine if you need to check the endpoints.